Welcome back. This is episode 2 for the DISK LRU cache, and we'll continue our implementation for the DISK LRU cache. If you haven't watched the previous episodes, I advise you to go take a listen and understand what we did in the previous episodes. We created an interface, and we wired up a few of these components. And if you truly want to understand what approach I'm using to kind of build this cache, then I'd advise you to look at the first 2 episodes that cover the requirements and design. Okay, that said, let's do the first phase of implementation for this cache, and that is we'll attempt to store most of the cache items in memory, but we also need to make that thread safe. So let's keep that in mind. So first we need a dictionary or a map where we will hold on to our items in cache. And for that we will use a linked hash map. Let's make this type string and byte anyway, and it's using some defaults there. Let's just ignore this one. Don't worry about that for now. And so we have our linked hash map, and the linked hash map maintains the order, and that's why we use it. Now if you're interested in learning about how to build an LRU cache in memory from scratch, you'll find a ton of videos on YouTube that talk about how you can use a dictionary and a single linked list or a doubly linked list maybe, and then build your own LRU cache. But this our focus here in all of these episodes are going to be trying to build a persistent disk LRU cache. So we'll just use the linked hash map for now, and linked hash map maintains order, and that will become quite important to us. And you'll see as we implement it how we employ the use of a linked hash map to achieve the same result. And then one of the other requirements was to have like a thread safe implementation. So we'll use a re-entrant read-write lock for now, and we'll guard the changes to this map through the use of the lock. So let's do some simple things first, right? Let's try to ensure we can fetch a key and store a key given this key is in a map in memory right now, right? So when you want to fetch a key, all we are going to do is we are going to attempt to get the key, and usually that's what we would have done, right? But we needed to ensure that this is also thread safe. So let's acquire the relock and unlock. Now usually when you acquire these locks, right, I mean it's much like we do it in Java as well. We want to kind of wrap them in a try finally, and in that way you ensure that you don't leave the lock locked if any conditions were to arise that cause a crash, or if you were to exit out of this code block without releasing the lock. Alright, so we'll continue to use the re-entrant read-write lock for now. The principle here is that when the write lock is acquired, read lock, the readers will wait and until the write lock is completed, and the write lock will wait until readers are completed at the same time. But the important rule to remember here is write lock can be downgraded to a read lock, but the reverse cannot be done. Right? Now we'll come back and revisit this later and see if this re-entrant read-write lock is the right way to go, or if we just use a synchronized, or we'll just do the job for us. For now, I'll just roll with this, and then we'll come back and refactor it later. But it seems like we have a simple fetch and store in place now. The only thing we need to care about is what happens when you exceed the memory requirements that are uh, that's been given to us by the developer. So that's something we need to reconsider while we store a key in in the map, right? So one thing I would do is um, have something like a loop in here to somehow, like, let's just type that in here. Okay. Loop entries in cache, and remove the oldest entry while the size constraint is not met, right? Uh, constraint. Sorry for the mistyping there. Constraint. For some reason I can't spell that. But yeah, so we do that. And where do we get that from? So that should be let's declare a where next current size is equal to 0. Almost right. And my current size is greater than or equal to cache config dot max. I think I'm using some brackets here, so let's get that done. And this config. Save. Solves that problem. Max size on disk. Size and remove okay, this doesn't look right, so it's autocomplete. Usually this doesn't work the way I expect it to work, so we'll just do a while entry is equal to get on map dot entries dot iterator dot next and then we remove this entry entry dot length. It's binary, so size entry dot value, right? That's what we want. Dot size. Okay. Entry dot key. Yeah, so that should basically keep our memory size in check. What's going on with this max on disk? Oh yeah, we should have made these values. Just make sure these are accessible to our code. There you go. That solves the problem. So yeah, now this will take care of what you've essentially done is done a fetch and store with a LRU map that is in memory. While we're at it, should we? Yeah, I think let's come back later and fill in the other two functions as well.